Hey, we made it to the end of the unit. This is just going to be review, and the review is going to cover all 4 types of transformations. I think a screenshot of this is really handy, and you could reference it for every single problem. I'm not really going to refer to it past right now because I don't want to keep going back and forth, but you can look at it for every single problem. What I think is the best way of handling this is you go ahead and complete the whole assignment. Pause the video, do all the questions, and then when you're ready, come back to the video and I'm going to do just a very brief explanation and go through the answers. Okay, so at this point, I'm assuming that you've completed everything. If at any point you feel like you need to pause to keep working because you want to change things, go ahead and do that. But otherwise, I'll just be going through the answers. You could also feel free to skip around the video. So I'm assuming you have already completed everything as I talk about this. Problem 1. So they're wondering how this was moved. Something to remember is that since this figure has all the primes on it, that means that is the post image, or the figure, you could call it. So it's going from right to left. So the correct answer would be D, 7 units to the left. You might have thought it was 3 if you counted from A to B prime, but you have to go from A to A prime. So 7 units to the left, answer D. Problem 2, the one that is a flip is D. The other 3 are all rotations. If you kind of line up this guy, you can see that it looks like that it has flipped over that line. Everything else can only be created by doing a rotation. Okay, this is one big problem on this page. So rotating 90 degree clockwise, you could also think about that as a 270 degree regular rotation because we like counterclockwise. So that means it's going 3 quadrants because it's 270 degrees. So it should end up in quadrant 2, which means that B is the correct answer. If you did like to think about it as 90 degrees clockwise, though, you could think about it as jumping 1 quadrant in the clockwise direction. That's if you're able to think of both the clockwise and the counterclockwise rotations. For some people, that's hard. So just kind of whatever is easiest for you. All right, we're rocking this. We're going to keep going. So let's see. So this is saying what transformation is used to show that they're congruent. So let's see. I selected C for this because essentially what that's saying is that the X and the Y's are staying in the same position, but we're taking the opposite of X. That's what it means to multiply each X coordinate by -1. And you could actually test that out if you were to list out what these 3 coordinates are. So what's happening here is it is a reflection over the y-axis. And the rule that I have down below that I wrote, that's what happens when you reflect something over the y-axis. So I'm not going to do all the points, but to give you a basic idea, if I call this Q, which would make this Q prime, Q is at -2, 1, 2, 3, 4, 5, 6, 7, 8. Q prime is at +2, 8. So yeah, that is what happened. The X coordinates got multiplied by -1, or in other words, we took the opposite of it. And you could test that out on all the points and it would work out. So C is correct. A is not going to work because that is a translation. But this was clearly flipped. It wasn't just slid over. D is not going to work because this is not a rotation. It looks, again, like it was clearly flipped. And B is not going to work because that would actually end up down here. That would be a flip over the x-axis instead of the y-axis. So there you go. All right, so Let's see. So it's a reflection, but it's not over an axis. The mirror is a line below the axis. Just visually, I can eliminate these guys right away, because if this is the mirror, there's no way it could end up on the right half of the graph. So I'm looking at B and D, and it looks like this point for a sample is 2 above the mirror. So I know it needs to go 2 below the mirror. So there should be, if this is like A and this is A prime, there needs to be a point at -2, -2, it looks like. And, oh, I miscounted. Not -2, -3. Because it's 3 down. 1, 2, 3. 3 down. -3, -2. So choice D is the one that has that. B, it looks like they flipped it over the axis. They didn't flip it over the dotted line. Okay. So let's see. Clockwise 90 degrees. Oh, counterclockwise. I missed a word. Counterclockwise 90 degrees. About point P. So we haven't really done a lot of rotations that don't have the center as the origin, but we can still just kind of visualize it. Point P is pretty close to the origin. So let's see. Counterclockwise 90 degrees tells me that instead of coming off in this direction, we're going to jump 1 quadrant counterclockwise, and it'll kind of be in this direction instead. So if here's my original shape, my new shape will be somewhere over here. So it looks to me like choice D is the one that has that option. So 90 degrees is like jumping 1 quadrant, basically. The fact that P is not the origin didn't really change much. It just kind of shifted everything over. Alrighty. So, let's see. We want a single reflection over the y-axis. So I'm looking at this each time. And right away, A jumps out to me. That's the only one that is using my green line as a mirror. Nothing else is using it. D looks like it's a rotation. B is a translation. C used the x-axis instead of the y-axis. Okay. Reflected over x, then reflected over y. So I want to visualize that first before I look at my choices. So that's the reflection over x. So it's going to look something like this. That's the first one. And then I reflected over y, which makes that one my final product. And that's going to be choice D. So I like to try it out myself first and then see which ones match up with it. Okay. 9. So we want to translate it 5 right and 2 up. So that means for the x coordinate, 5 right means you're adding 5 to x. Right is making the number more positive. 2 up means you're adding to y. Again, you're making it more positive. So we may just need to test it out on one of these points. One of the example points they give us is -5, 2. So performing that translation on it, that's going to make it 0, 4. So right away, A is calling out to me. And I'm just scanning the other ones to see if anything else also has 0, 4 to see if I need to check other points. I'm not seeing it. So A is the only one that could work. And I mean, if I were taking a test, I would check the other 3 points. But I'm not. So A is going to be my answer. 10. So here's a triangle. And we want to reflect it over the x-axis and translate down 2 units. So since they're looking for coordinates, I'm going to pick one of these coordinates out, kind of like what I just did on the last problem. I'll pick R. So that's 3, -4. Step 1 is to reflect it over x. So that means I need to apply the rule, keep x the same, take the opposite of y. And I'm not expecting you to have that memorized. You could have looked at this screenshot. So applying that rule gives me 3, 4. So that's where r should be after the reflection. And now translated down to units means keeping x the same and taking 2 away from y, making it more negative, making it go down. So that makes it at 3, 2. So is there an option that is 3, 2? The only one I'm seeing is D. Again, if I were taking a test, I would test out more points, but I think this is good enough. And then 11. Let's see. To me, it looks like we're just flipping it over and over. So flips it over the orange line, flips it over the purple line, then it flips it over the green line, and it keeps going. So to me, that's just a reflection. Over and over and over reflection. You might think about a transformation or a translation because it's like also moving to the right, but then the direction wouldn't change. It would look like it just slid over. But this is clearly being flipped because the shape is flip-flopping and changing and becoming like a mirror image each time. So that's why it's a reflection. Okay, almost done. Oh, let's see. 4 problems on this page. 5 problems on this page. Big page. So which preserves the dimensions? So this is basically saying which ones are isometries. In other words, which ones are congruent. The only one that's not an isometry is dilation. So I can eliminate all of these choices because those all have dilation in it. A is my answer. Okay, so we are going 2 units down and 5 units right. And they're only asking about x. X looks to be at 1, 6. So I'm applying the rule 5 units right is x plus 5. 2 units down is y minus 2. So 1 plus 5 is 6. And 6 minus 2 is 4. So D is correct. Okay, if a polygon is translated, which of the following characteristics of a polygon are the same? So a translation is an isometry, which means it's going to be congruent. Same size, same shape. The coordinates won't stay the same, but the side lengths and the area will because it's a congruent figure. You've just moved it over. The shape and the size don't change. So the exact same shape moved over would have the same lengths and the same area. So 1 and 2. The coordinates will be different though because it's in a different location. And that's actually why we say they're congruent and not equal. If the coordinates were the same as well, the shapes would be equal to each other. But since it's moved over, we just say it's congruent. Okay, we're almost done. So reflected across the x-axis. So here's my mirror. And we're only asking about M. So the original M is, let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5. And the rule for reflecting across x is you keep x the same, take the opposite of y. So M prime would have to be at 4, -5. That's choice C. One last one. So it's translated 3 units to the right and 2 units down, and they want point X. X looks to be at 2, 5, and 3 units to the right means X plus 3. 2 units down means Y minus 2. So 2 becomes 5, 5 becomes 3, and that's choice C. Okay, that finishes that up for today. Thank you.